All right, on to our next video, the derivatives of logarithmic functions. We're going to have x is greater than 0 and f of x equals the natural log of x. Again, we'll switch to different bases in the next section. If we take the derivative of the natural log of x is 1 over x. And if we do f of g of x, like natural log of g of x, it's 1 over g of x times g prime of x. These are just something you have to remember. Okay. We can give a proof though. For x greater than 0 and y equals natural log of x, then x equals e to the y. I said inverse functions there, but that's not true. Those are just different ways of writing the same thing. So let's get rid of that wrong script right now. So we've got x equals e to the y. We use implicit differentiation. We take the derivative of the left side, we've got 1. The derivative of the right side, we already saw the derivative of e to the anything as itself, times the derivative of the exponent, and that's going to give us a dy dx. So e to the y dy dx equals 1. We solve for dy dx, so we divide by e to the y, but e to the y was x. So when we plug it in, we've got dy dx equals 1 over x. Bam. That's how we show that the derivative of natural log of x is 1 over x. The chain rule just expands on it. Let's take a look at another one. We're going to find f prime of x if f of x equals the natural log of 4x to the 4th plus 3x squared plus 1. So if it helps you, say u equals 4x to the 4th plus 3x squared plus 1. So du dx equals 16x cubed plus 6x. And ddx of ln of u equals 1 over u du dx by the chain rule. That's what I've got here. You literally take what's in there, you put it on bottom, and then you take the derivative and multiply by it. Okay? So when we do that, we've got 16x cubed plus 6x on top. We've got 4x to the 4th plus 3x squared plus 1 on bottom. And we've got the derivative. Bam, done. What about finding f prime of x for f of x equals natural log of x cubed times cosine x all over 4x plus 5? Now, I'm sure your first thought is doing 1 over that and then doing the quotient rule. But we're not going to do that. Let's do that. Let's do the easy way first, and then I'll show you the quotient rule way in a second. The easy way is expanding using the properties of natural logs or logs. So when something is divided by another, it turns into subtraction. So we've got ln of x cubed cosine x minus ln of 4x plus 5. And when we have two things multiplied together, they turn into a plus sign. So we got ln of x cubed plus ln of cosine x minus ln of 4x plus 5. Then we've got f of x equals, another property is if y equals ln of x to the n, then y equals n ln of x. You bring exponents down, so I brought the 3 down. We have f of x equals 3 times the natural log of x plus natural log of cosine x minus natural log of 4x plus 5. This is as simple as it gets. Now we take the derivative, and anything we got in natural logs, we put that on bottom, and then we take the derivative of it. So ln of x turns into 1 over x. You could take the derivative of the inside, but it's 1. So we've got 3 times 1 over x. On the next one, the derivative of natural log of cosine x is 1 over cosine x. Then we have the derivative of cosine x is negative sine x. And then we're subtracting the derivative of natural log of 4x plus 5. That puts 4x plus 5 on bottom. Then times the derivative of 4x plus 5 is 4. We clean that up. We get f prime of x equals 3 over x. We clean up the cosine x, 1 over cosine x times negative sine x. We just get a negative tangent x. And then we've got minus 4 over 4x plus 5. Now, describing and doing the full hard way mode is going to take like a 10-minute video. I'm going to like put it on the screen and just show you what would happen if you tried to do it. If you didn't separate it, you got to do 1 over the value of the inside times the inside, derivative of the inside. The derivative of the inside has a quotient rule and a product rule, which means after you go through all of that mumbo jumbo, this part here shows up as a denominator right there, and the quotient rule part is on top. Now we got a complex fraction, and you can clean this all up. It's hell. I ended up getting this value, this right here for f prime of x, after we got it down to a simple fraction. Supposedly, that cleans up to what we had up top. This nice little 3 over x minus tangent x minus 4 times 4x plus 5. I don't want to even try to do the work to get it, but look at how bad that is. Look how horrible this is. Ugh. So, don't do the hard way. When you have natural log of a bunch of crap inside, expand it out like I did up here. Okay? You can go pause this video and go through the hard way if you want to see it and follow everything I did. But I think you would agree just by looking at it, that is a big hell no. Okay? Why don't you guys try doing f of x equals natural log of 3x plus 2 to the 5th power like that. And then also do it with the 5th power on the outside of the natural log. Pause the video and take a shot at it. All right, I will assume you did that. If I do the one on the left, I've got 1, we're taking the derivative of what's on the inside, so we do 1 over that, and then we do times the derivative of what's on the inside. So that brings the 5 down, lowers the power by 1. We got 5 times 3x plus 2 to the 4th power, and then we take the derivative of the inside of that, which gives us a 3. And when we clean that all up, we get 15 over 3x plus 2. Here we could have also applied the properties of natural logs, brought the exponent down, and it makes the derivative a lot easier. I showed both methods there. You can see you get the same value. These are the same. On the right one, the 5 is on the outside of the natural log, so you can't bring the power down. Not like the properties of natural log, not like I did here. Can't do it like we did here. Just got to take the derivative as a chain rule. This is like having a u equals ln of 3x plus 2 on the inside, and we're doing u to the 5th. So we have 5u to the 4th right there, but u is ln of 3x plus 2. Then we take the derivative of ln of 3x plus 2. That gives us 1 over 3x plus 2. And then we take the derivative of the inside of that. The derivative of that is that. Clean it all up, you get this. You'll notice we do get different things. Where that exponent is does matter. Is it on the inside of the natural log function? If it's on the outside. So do not write ln 3x plus 2 to the 5th power like this. It's confusing. Which one is it? The textbook, I think, does this, and it's sloppy. It's confusing. You don't know where the 5 is in terms of, is it on the parentheses or is it on the whole natural log? So try to make sure you're using grouping symbols like parentheses and brackets and stuff like that well. Next video, we'll do derivatives of general exponents. Let me stop recording on this one.